One of the things I help companies with is to build computer vision applications for edge deployment. And when it comes to edge deployment, by far the most common platform for me to work with is the AXIS network cameras. And in fact, I almost exclusively recommend the AXIS cameras when it comes to internet-connected surveillance cameras. And that is because of many reasons, but one of them is the SDK, because the SDKs that you get for AXIS cameras are really quite nice compared to the SDKs that other camera vendors have. So when starting with building an application for an AXIS camera, one of the first questions you should ask is what SDK are we going to use? Because that really affects greatly the architecture of the application and also what cameras you can deploy your product to. A few years back it used to be quite easy. Then there was two SDKs. It was SDK 1 and SDK 2. And if you wanted to support cameras pre-firmware 570, then you used SDK 1. If you wanted to support newer cameras, then you used SDK 2. And if you wanted to support both of these firmware versions of camera models, then you needed to build both with SDK 1 and with SDK 2. Today we have a little bit more to choose from. We have also the SDK 3 and we have the two versions of the SDK 4, the native and the computer vision one. And SDK 1 and SDK 2 are deprecated, so you shouldn't use them anymore. But that still leaves 3 different SDKs to choose from. And it's actually been really exciting to work with AXIS applications the last few years, because it's been so much happening on the SDK and API front. But it does also create a bit of confusion and make it more complex to know where to start and what to look for. But the fact is that once you know what you're going to use and how you're going to use it, it is actually a lot easier with the new SDKs than it was with the old ones. And it also gives you a lot more functionality and power that we didn't have before. So this is really a great thing. So we're going to start all the way to the left with SDK 1, and we just go through the different SDKs and see what are the differences. And then in the end we discuss, if you're starting with a new project now, what SDK are you going to choose? So going back a decade or so, a little bit more, we had the launch of SDK 1. And that was really a game changer for using AXIS cameras, because before then there wasn't really any way to build applications in a consistent and robust way for AXIS cameras, and also to make it easy to install them for customers. So that was really an amazing thing, and that lived for many years, all the way until firmware 570. And at that point there was actually quite a few big changes in the firmware and the camera runtime itself. So for example, the BOA web server was replaced with Apache web server, and the old Telnet configuration was replaced by SSH instead. So that created a quite strict break where you need to use the correct SDK depending on what side of this firmware version boundary you were on. And then we had SDK 2 for many years. Didn't actually move very rapidly at that point in time. But that was a useful SDK that lived for a long time. And then quite recently we have the introduction of SDK 3, which is officially supported from firmware 970. And in the change from SDK 2 to SDK 3, there wasn't as much changes in the actual runtime or the build environment. There were some small changes. So for example, the package.conf file was replaced with a manifest.json file, which is much nicer to work with and gives a more modern feeling and better validation. But it is still backward compatible, and you can use it with a package.conf file that works just as fine basically, and there are also scripts to automatically convert from the old configuration file to the new manifest file. So one of the other changes was that there was a quite nice bump in the GCC version. So I think we moved from GCC 4.7 to GCC 8 or something like that. I think now SDK 3 get delivered with the GCC 9. So that's quite nice. You get some extra functionality as behavior sanitizer and memory sanitizer and that kind of stuff that GCC offers nowadays. But the thing here is that the boundary in the firmware isn't as strict as it was before, because you can still use the SDK 3 to build for older firmwares, even though it's not supported by the documentation. So basically, you have in the manifest file, you can specify the required embedded version, and that will tell the runtime if the application is installable or not on the firmware. So the idea with this is that different libraries that are actually included in the camera runtime and gets linked to dynamically by the application, they can change. So you should set that correctly to reflect what the requirements your application have. And if you are being a bit careful, you can actually go further back using SDK 3. And then recently we had the launch of SDK 4, and this comes in two different flavors. So you have the native SDK and you have the Computer Vision Sdk. The native SDK is quite similar to SDK 3 when it comes to the build environment and the deployment and so forth. So there are some minor differences, but not really anything much to talk about. But the big change here is that some of the libraries that was available in SDK 3 was removed. And 3 of the libraries that I think will hit most of the application developers is that the axhttp library that was used to create web pages dynamically using fcgi, so that you could get APIs to call your C code. That has been removed from the native SDK. And instead, the recommended solution is that you include your own web server in your application, and then you configure Apache in the camera to make a reverse proxy to your own server that is only listening to local hosts. And that way you can use Apache to terminate the SSL connections for HTTPS, and you can use it for user authentication by having different endpoints on your server and configuring the reverse proxy in different ways depending on what users should be authenticated or not in their web. So that will likely require quite much change in the architecture depending on if you're going to use the SDK4 or if you're going to use the traditional way in SDK3. But of course you can still use the SDK3 to include your own web server too. And another thing that is changing is that libcapture was removed. So I think a lot of old applications were depending on libcapture, but since a while back there have been the video stream library that is the recommended solution for using capture, be that raw or be that encoded. So that is just refactoring that needs to be done from using the old capture library to the new video library. And then another thing that has been removed is the xparams library. And that one can be a bit more dramatic to change, because there isn't really anything, any option offered for that. So in the old SDK, up to SDK 3, what you could do there is to include in your application a configuration and parameter specification, and the runtime will automatically create these parameters in the camera parameter handler when installing the application. So if you go to the application tab and click on your application, you will directly have this field where you can configure different parameters, and that way you don't need to run your own web server just to do some simple configuring. And you can even access these parameters through the APIX API. And this is not possible when building with the ACAP 4, or at least the library is not included there. So what you need to do then instead is to build your own web page and implement your own parameter handler that saves your parameters to a file on the flash storage, for example. So that is the major differences between SDK 3 and SDK 4. And SDK 3 is still supported officially, but AXIS says that they are not delivering any new features to it. So my recommendation would be to use the SDK 4 as possible, because then you don't need to do another transitioning when it's actually time for SDK 3 to get deprecated. But of course, if you're making a very simple application and you know that you don't need the new features in the new SDKs, then perhaps it will be faster to use SDK 3, since you can rely on the camera's web GUI for your parameter configuration, for example. But that is a risk you're taking then, that it might not be supported for very long. So then we get to the Computer Vision SDK. And this is really quite different from all the other SDKs. Because the SDK 1, 2, 3 and native SDK 4, they are building the applications into the same kind of application package, the EAP file, which has been basically the same format all the way since the launch of SDK 1. And Computer Vision SDK is instead relying on Docker. So the major difference between the native SDK and the Computer Vision SDK is that the native SDK is typically aimed for C or C++ applications, and they are built into a package file that is easy for the user to install. So if a user gets application as a package file, then he can just go to the apps page and he can install it using the add button, and it will turn up as an application here, where you can control the running state of the application, you can see the status of it, and you have some other functionalities. Those things you don't really get with a Computer Vision SDK. Instead, it is just relying on Docker and running behind the scenes. So one thing there that differs is the deployment. The other thing that differs is that it is a much more high-level SDK. So it has Python binaries pre-compiled for the camera, and you have a lot of Python libraries such as NumPy and TensorFlow serving built into the SDK. So when it comes to the functionality in it, you can say that it is basically an abstraction on top of the native SDK. So in the native SDK, for example, if you want to do deep learning, then you make use of the liblarod library, which is a C library for inference. While in the Computer Vision SDK, you have instead TensorFlow serving, which comes with a model server where you can include your model, and this model server in turn makes use of the underlying liblarad that is included in the native SDK. And the same for image capture. While in the native SDK you would use libvideostream, but in the Computer Vision SDK you have instead the more standardized format of OpenCV capture. And this OpenCV capture is delivered both as C++ library and as a Python library for Python applications. And this library is then in turn internally using the underlying libvideostream library. And then when it comes to the deployment, the Computer Vision SDK is really nice for prototyping, for example, because then you have the camera close at hand and you can use your Docker commands to actually push the image to the camera and start it. And you can also install an ACAP application for Docker Compose to make it easier to start multiple containers. But on the other hand, if you want to deploy your application to customers, then this can make it a bit hard because they don't have the knowledge to pull a Docker image to the camera. So there are basically two different options. Either if you have access to the cameras, then you can automatically deploy it somehow. Or another option is to make use also of the native SDK4 SDK to build an installable package file. And this package file might then either pull down the latest Docker image and start that, or it can actually include the Docker image as a tar file in the package itself and then install it locally when the application is installed. So when it comes to deciding what SDK you should use, SDK 3, native SDK 4 or the Computer Vision SDK 4, I would say that deployment is one of the important things, and choice of language is another of the important things. If you're very used to work with Python, then it is very nice to work with Python on the camera also. And to do that, it is definitely easiest to use the Computer Vision SDK where Python is actually supported. But then you will be limited to the number of models, camera models that you can run your application in. So this is typically the more expensive models. And this is because the containerd and Docker takes quite much space. And also typically Docker containers that you deploy will take a lot more space, and you will often have duplicated libraries and so forth, which keeps the isolation from the camera system itself, which is very good from a robustness point of view. But it does take more flash. And for example, if we look at one of the standard companion line cameras or the low cost M line, then we typically have something like 256 megabyte flash and 512 megabytes RAM. And 256 megabyte flash is just not enough to use Docker on the camera, at least without installing an SD card or using a network storage. And then if we look at ARPAC 7 cameras, for example, so one of the cameras that are supported by the Computer Vision SDK is the ARPAC 7 camera Q1615 Mark III, which is also equipped with a deep learning unit. And that camera has 1 gigabyte of flash storage and 2 gigabytes of RAM. And now with the launch of ARPAC 8 cameras, for example, if we take the P3265 camera, that one has 1 gigabyte of RAM and 8 gigabytes of flash. So there you can really see how the flash has been scaled up from the M line 256 megabytes to ARPAC 7 1 gigabyte, and now this ARPAC 8 camera with 8 gigabytes of flash. So that really makes it easy to develop applications in Python, for example, and using the Computer Vision Sdk. But those cameras are, of course, also a bit more expensive. But with the introduction of ARPAC 8, I think we will see a lot more cameras which are reasonably priced and have really nice performance. So that might be a very good option for many companies. And the native SDK 4 versus SDK 3, I would in most cases recommend SDK 4. If you want to go on a firmware before 10.7, you have either the options to build with both SDK 3 and SDK 4, which I don't really think makes a lot of sense if you don't want to include different functionality based on what kind of models you deploy it to. Another option is to just put the required embedded version to a lower version, and you can probably run it on older firmwares too. But it's of course not as robust. You're relying more on yourself since it's not officially supported. And the third option is of course to use SDK 3, but then there's a big chance that it won't be very long-lived before you need to rewrite it to support newer camera models. So for simple applications where you want to rely on the libraries that was available in SDK 3 but doesn't exist in the native SDK 4, then yes, you could consider using SDK 3. And if you want to use a simple application, not a lot of features, with a wide range of supported cameras, yes, then sure, also go ahead with SDK 3. But otherwise, I would default to the native SDK 4 in those cases. And also for computer vision application, although the name of these two versions of the SDK 4, it is totally possible to build computer vision applications with the native SDK 4. The LaROD daemon for utilizing the DLPUs and the deep learning processing units, they are also included in the native SDK 4. So you can definitely build complex deep learning applications there. So it's more a question about what language you want to use and how you want to deploy the application.